Hey guys, this is the video for geometry for Tuesday, January 26th, and it's on the fourth type of transformations that we're going to talk about this unit called dilations. So a dilation, I'm sure you've heard that word before in the context of like your pupils are dilated or something like that. And a dilation is just a change of size. That's it. And if the figure gets bigger, this is called an enlargement. And if a figure gets smaller, this is called a reduction. All right, another thing you need to know about this is something called the scale factor. So the scale factor is just how much bigger or smaller it gets. Okay, so if the scale factor, let's say the scale factor is like abbreviated by the letter K. If K is greater than 1, then it's an enlargement. And if K is less than 1, then it's a reduction. Okay, now we've talked about symbolic notation for all the other types of transformations. Remember, capital T is a translation, lowercase r is a reflection, capital R is a rotation. So this one is just a capital D. So the notation is capital D subscript K. Okay, so like for example, they might give you something like dilation scale factor 2 of the 0.53. And all you're going to do to get the image of a dilation is just multiply the scale factor by each of the coordinates. That's it. This is just going to end up being 10, 6. Okay, so to get the image of a dilation, you just multiply each coordinate my pen's running out by the scale factor. It's that simple. Okay, remember for each of the other types of transformations, we had a way to get the image. Sometimes it was by graphing, like in the case of reflections and rotations, and sometimes it's not by graphing, like for translations we had to add, right? So in this case, we're just going to multiply. Okay, so if I had something like, let's go to graph paper here. If I had something like, for example, the dilation by scale factor 1/2, and the pre-image was the point -6,4. Okay, if I start at -6,4, 1, 2, 3, 4, 5, 6, and 4 down, right there, and the dilation scale factor is 1/2, that means I'm going to multiply each of these coordinates by 1/2, right? So I'm going to get -3, 2. -3, 2. Whoops. What am I doing? -6,4 is actually up here. -3, 2 is here. So essentially what you're doing in this case is you're taking the point half as far away from the origin as it once was, right? Like you have this imaginary line that connects the pre-image point to the origin, and you're just getting closer and closer to it. Okay, if you did this to an entire geometric figure like a triangle or something like that, you can see what would happen. Like if I took a triangle and it was like this, and I took each point half as far away from the origin as it was at first. Like this point right here, if I went along this dotted line and I went half as far away from the origin, it would end up being there, right? This point, if I went along this line towards the origin, it would be there. This point, if I went along this line towards the origin, it would be there. I'd end up with a triangle that's smaller, but it's also closer to the x-axis or to the origin than it once was. Okay, so that's what's really happening with an enlargement or a reduction. For an enlargement, points are just expanding out away from the origin. For a reduction, points are shrinking in closer to the origin. But the net result is side lengths are going to be, in this case, half as long, right? You're going to end up with a similar figure with a scale factor or a similarity like ratio of 1/2. Okay. Let's do one more example. So if I had something like, let's just look at what happens if it's negative. Like what if I had something like a dilation by scale factor negative 1/2 or negative 2, let's say, of the point 2, negative 3. Okay, so 2, negative 3 is here, right? If I dilate by negative 2, I end up getting negative 4, 6, right? If I multiply each of these coordinates by negative 2, well, what happens then is not only do points get twice as far away, but it actually gets reflected through the origin as well. So 2 or negative 4, 6 ends up being over here. Okay. So if the dilation factor scale factor is positive, then it just gets further away or closer to the origin. If the dilation scale factor is negative, then it gets further away or closer to the origin, but it also gets reflected through the origin. So it ends up like in the opposite quadrant. Okay. But the bottom line is, to get the image of a dilation, all you have to do is multiply the coordinate by both coordinates by the scale factor. That's all there is to it. Okay, let's just review for a second. So we've done 4 types of transformations so far, right? We've talked about translations, and remember, the quickest way to get the image point in a translation is to add. So if I have a translation of AB and the point is XY, then all I'm going to do is just add A to X and add B to Y. Okay, that's the best way to get the image in a translation. Then we talked about reflections. And the notation there was lowercase r with a subscript of a line, the equation of a line. It could be x equals 2, which would be a vertical line, or it could be y equals x minus 7. That would be a sloped line, slope 1. Okay, and for these, just graph it. That's definitely the easiest way to get the image. Then we talked about rotations. So remember, for rotations, we had capital R and then a certain number of degrees. Angle, let's see, we'll just say A for angle. And again, you're just going to graph it. You're going to graph the pre-image point and then actually physically rotate your paper 90 degrees or negative 90 degrees or whatever, or 180. And then finally, we have dilations. And the whole idea here is, if you have capital D with a subscript of a scale factor, all you're going to do is just multiply. It's going to be K times X and K times Y. Right? So that's kind of a summary of what we've done so far with transformations. We're going to have a quiz Wednesday on translations and reflections, which were the topics in this unit that we started last week. The quiz is going to be 15 minutes. timed on Delta Math. So make sure if you're in person, make sure you bring other work to do for the remaining time. All right, that's all I have for today. Thanks for watching. Be sure and smash that like button. Have a good day.